In this video, we're going to be looking at radicals. First thing that we're going to do is use our calculator to find square root, cubes root, and fourth roots. Then we're going to be looking at more complex radicals that we're just going to solve by hand. And then the last thing that we're going to do is to simplify fractional expressions by rationalizing the denominator. All right, so the first problem I have here is the square root of 49. And you can probably do that in your head and get the answer of 7. If you want to do this with the calculator, then you need to access the square root key, which is right above this x squared key. It's a second function key, so I have to hit second and then that square root key, and then I can type in 49. And if you want to, you can scroll over to where that cursor is outside the radical sign and press enter, and you get the answer of 7. Okay, with the second problem here, you can see I have a negative out front of my radical sign, and you're going to have to type in this negative first. So it's down here at the bottom, right by the decimal. So I have negative, and then the square root symbol, 25. And again, I can move my cursor out from under the radical sign, press enter, and I get -5 for my answer. Okay, the next problem I have is a cubed root. So what I'm going to do here, let me clear this, is access this key on the left of my calculator that says math. And then I'm going to scroll down till I get to that fourth option where I have a cubed root. Press enter, and you can see my cursor is already under the radical sign, so I can just go ahead and type in 125, and that's going to give me the answer of 5. Okay, problem 4, I have the fourth root of 625. So again, I'm going to go to this math key and scroll down till I get to this fifth option where I have the nth root here. So press enter, and you notice that my cursor is up here at my index. I'm going to type in 4, scroll over, and then type in the 625, and then press enter. To the fourth root of 625 is 5. Now, if you have an older version of your calculator, you may not be able to do the problem that way. You may need to type in the 4 first and then go to that math key. Okay, with problem 5, there's a couple of different ways that I can do this. I can put this in the calculator just like it appears, or another way to do this, and what you should be able to do with a smaller number like this, is to realize that this is going to be the same thing as the square root of 81 divided by the square root of 16. And then you can take the square root of each of those. The square root of 81 is 9. Square root of 16 is 4. So your answer is 9/4. Okay, now remember, sometimes you need to simplify by factoring the number under the radical sign, where you have the square root of a perfect square times a whole number. And what I'm going to do first of all is come over here and make a table of perfect squares. Okay, now here are all my perfect squares. And I like to start my table with 1, but really we don't use this. Okay, the first problem that I have here that I need to simplify is the square root of 500. Now my table only goes up to 100, so if you want to go past that on some of your problems, you can, but I don't think you're going to need to do that on most of them. The biggest perfect square that goes into 500 is 100. So I'm going to write this 500 is 100 times 5. Now I'm going to go ahead and break this up into 2 different radicals, the square root of 100 times the square root of 5, and the square root of 100 is 10, so I have 10 times the square root of 5 for my answer. Now, you may not need to put this step in here, but it doesn't hurt. Okay, problem 7, I have the square root of 45, so I'm going to look to find the biggest perfect square that goes into 45. So you start down here at the table and then work your way back up. you're going to find that the biggest perfect square that goes into 45 is 9. 45 is 9 times 5. So I can break this up to the square root of 9 times the square root of 5, and the square root of 9 is 3, so my answer is 3 times the square root of 5. First thing you need to understand here is that the 7 right next to that radical sign means 7 times the square root of 12. And what I want to do is to simplify that square root of 12 just like I did previously. I want to find the biggest perfect square that goes into 12. And the biggest perfect square that goes into 12 is going to be 4. So I'm going to write this square root of 12 as square root of 4 times 3. And then I'm going to go ahead and write this as two different radicals, square root of 4 and the square root of 3. Now the next thing I want to do is to simplify that square root of 4 and get 2. So I'm going to have 7 times 2 times the square root of 3. And 7 times 2 is going to give me 14. So I have 14 times the square root of 3 for my answer. All right, let's do one more here. Problem number 9. I have 5 times the square root of 3. Again, I want to find the biggest perfect square that goes into this number here that's under the radical. So the biggest perfect square that goes into 63 is 9. I'm going to go ahead and skip a step here, and I'm going to go ahead and write this as the square root of 9 times the square root of 7. The square root of 9 is 3. So now I have 5 times 3, which is 15. So I have 15 times the square root of 7 for my answer. Okay, on these next few problems, we're going to be looking at a little bit more complex expressions where we have to simplify. Your first step is to try to simplify what's under that radical sign, just like we've been doing. Right? So with problem 10, you can see that there's nothing I can simplify here. Square root of 5 is just square root of 5. Problem 11, I have square root of 50. So I can simplify that. Right? That's going to be your first step, simplifying what's under the radical. I don't really want to start with one of these harder problems, so I'm going to go ahead and start with problem 10, where there's really nothing for me to simplify. So that brings me up here to this. Reminder, when you have more than one term in the numerator, you need to factor out a GCF when possible. So I need to find the greatest common factor of 9 and 6 and 3. What is the biggest number that goes into all three of those? And the biggest number that goes into all three of those is 3. So I can factor out a 3. So I have 3 minus 2 times the square root of 5. And then in the denominator, I have 3. So now the 3's will cancel. So my answer is going to be 3 minus 2 times the square root of 5. Okay, problem 11. Again, I'm going to start off by simplifying what's under the radical sign, the square root of 50. I can break that up into the square root of 25 times 2. And the square root of 25 is 5. So I'm going to have 10 plus 5 times the square root of 2 divided by 10. Now I'm going to look at these three numbers here and find the greatest common factor, which is going to be a 5, and I'm going to factor out a 5. So this gives me 2 plus the square root of 2 in the numerator. The denominator, I'm going to go ahead and write that as 5 times 2. And that way I can see that these 5's are going to cancel. So my final answer is 2 plus the square root of 2 divided by 2. Now, a common mistake is that students will want to try to cancel out those 2, or back up here on this step, cancel out those 10s, and you can't do that. Remember that you can only cancel out things that are being multiplied. You cannot cancel out things that are being added or subtracted. Okay, problem 12, the first thing I want to do is to see if I can simplify what's under that radical, that square root of 3, and it cannot be simplified. So the next thing that I want to do is to look at all of these three numbers here and see if there's a greatest common factor. And there is. I can factor a 2 out of all of those numbers. So I factor out a 2, and that will give me 3 plus 2 times the square root of 3 in the numerator. And then in the denominator, I'm going to have 2 times 4. So now my 2's can cancel. So my answer is going to be 3 plus 2 times the square root of 3 divided by 4. Okay, problem 13. The first thing I want to do is see if I can simplify that square root of 8. And I can. There's a perfect square that goes in to 8. And the perfect square that goes in there is 4. So I'm going to have the square root of 8 to be broken up into the square root of 4 times 2. So the square root of 4 is 2. Now the next thing I want to do is to look at these three numbers and try to find their greatest common factor. The greatest common factor here is going to be 2. So factor out of 2. That leaves me with 15 minus the square root of 2 in the numerator. And then in the denominator, I'm going to have 2 times 20. So the 2's cancel. So my final answer is 15 minus the square root of 2 all over 20. Okay, for these next couple of problems, I would like for you to try to do these on your own. So pause the video, do those, and then come back and check your answers. Okay, remember when you are simplifying, you need to rationalize the denominator. So with problem 16, I have the square root of 3 in my denominator. So I need to multiply numerator and denominator by square root of 3. So in the numerator, I have 4 times the square root of 3, and in the denominator, I have square root of 3 times the square root of 3, which is 3. And if you need to put that in the calculator to help you out, you can. Okay, problem 17, I have the square root of 25 over 7. So the first thing I want to do here is to break this up into two different radicals. So I have the square root of 25 in the numerator, and I have the square root of 7 in the denominator. Well, I can simplify the top part of this fraction. Square root of 25 is 5. Now I can rationalize the denominator by multiplying numerator and denominator by square root of 7. And just as a quick aside here, I wrote this problem just slightly different than I did the first one, just to show you that you can. On this problem, I have one great big fraction, and on problem 16, I wrote this as two separate fractions. It doesn't matter to me. Now, in the numerator, I'm going to have 5 times the square root of 7 in the top part of the fraction, and in the bottom part of the fraction, you have 7. Okay, I would like for you to try to simplify problem 18 on your own. So pause the video, do that, come back and check your answer. And there's your answer. Okay, problem 19 is a little bit more complicated, so we need some more room here to do that. First thing I want to do is to split this up into two different radicals. I'm going to have the square root of 81 in the numerator. And then in the denominator, I'm going to have the square root of 28. And I'm going to simplify each one of these radicals. So the square root of 81 is 9. And there's more than one way to do this problem. Square root of 28, I'm going to break it up into the square root of 4 times 7. And the square root of 4 is 2. So in the denominator, I'm going to have 2 times the square root of 7. Now I need to rationalize my denominator. I'm going to multiply numerator and denominator by the square root of 7. So in the top part of the fraction, I have negative 9 times the square root of 7. And then in the bottom part of the fraction, I'm going to have 2 times 7, which is 14. And again, if you need to just stick all of that into the calculator to help you multiply that out, that's fine.